Suppose instead of wanting to find the probability that we have exactly some number of successes in a binomial experiment, we want to find a probability that we have X or fewer successes. We can do that with the binomial distribution as well, and it's really straightforward using the calculator in StatCrunch. So let's look at our example again of the 200 Americans who were interviewed about the importance of controlling gun ownership. Remember, the probability of success in this example was 0.47. We want to find the probability that 90 or fewer of the 200 interviewed Americans say it's important to control gun ownership. This is called a cumulative probability because we're taking everything to the left of 90. So we're adding up all of these probabilities for any outcome less than or equal to 90. And in StatCrunch, it's really straightforward. We're going to, again, plug in our N and our P. So we're going to tell StatCrunch N is 200, P is 0.47. Remember, we got here by clicking on Stat and then going to Calculators and then Binomial. We want the probability that X is less than or equal to 90. So make sure in that drop-down menu you choose less than or equal to and then plug in 90, and then StatCrunch will spit out the answer of 0.31. In fact, let's see that together here. So I'm going to open StatCrunch over here. Let's start from scratch. So I go to Stat, Calculators, Binomial. I need to tell it the number of trials. So in this case, we had 200. Our probability of success was 0.47. And now we want the probability that X is less than or equal to 90. And again, there it is, 0.31. What if I want the probability that more than 90 say it's important to control gun ownership? Well, remember, in a probability distribution, the sum of the probabilities must total 1. So that means if I want to know the probability that X is bigger than 90, well, that's the complement of X being less than or equal to 90. And so I can use the complement rule. So the probability that X is greater than 90 is 1 minus the probability that X is less than or equal to 90, which is what we found on the previous slide. So that's 1 minus 0.31, which gives you 0.69. Now we can also do this directly in StatCrunch by just changing our inequality here to a strictly greater than. Okay? It's important that you read the question carefully. This says more than 90, so that means that we're not including the 90. So we want the strict inequality greater than 90. And then we'll click compute, and out pops our answer, 0.69. What if I want the probability between two values? Well, up here in the top of the calculator, you can click on the between option, and it'll allow you to enter numbers between two numbers. So let's find the probability that we have between 85 and 95 inclusive, that means including the endpoints, that say it's important to control gun ownership. Well, again, I just enter N and P into the StatCrunch calculator, and I'm going to type in 85 for my lower bound and 95 for my upper bound. Notice this is the same as if I found the probability that X was less than or equal to 95 and subtracted the probability that X was less than or equal to 84. Let me highlight that here. So X less than or equal to 95 would give me this entire yellow region. And so that's more than I want, right? So I need to take off the part that's extra, and that's exactly this bar that starts at 94 and goes to the left. I'm sorry, 84 and goes to the left. That's the probability that x is less than or equal to 84. So if I take the yellow and subtract the blue, I get the red that I've now hidden that I wanted. Okay. All right, when we plug that into the StatCrunch calculator, we find that the answer is 0.496. Let's look at another example. According to the Bureau of Labor Statistics, the unemployment rate in Detroit in June 2014 was 10.2%. If a random sample of 15 people living in Detroit at that time was taken, find the probability that 3 or fewer were unemployed. So first of all, does this satisfy the criteria for a binomial experiment? So what do I need to check? First of all, is there a fixed number of trials? Well, I'm going to take a random sample of 15 people, and that's the fixed number, so that's good. What else do we need to check? Are there only 2 possible outcomes for each trial? Well, the outcomes are unemployed or employed, right? So that works. Our third condition is that the probability of success must be the same for each trial. Well, we know that in Detroit, the unemployment rate was 10.2%. So the probability of success in this case is going to be 0.102 in each trial. And finally, we want to know that our trials are independent. So does knowing whether the first person interviewed was unemployed affect the probability that the next person is unemployed? No, it doesn't. So these are independent trials. All right, so our conditions are met for a binomial experiment, so we can use the binomial formula or the binomial distribution with StatCrunch to find the probability. So we want the probability that 3 or fewer were unemployed, so we're looking for x less than or equal to 3 because it's 3 or fewer. All right. So I'm going to go to my StatCrunch calculator and I'm going to plug in n equal to 15 since there are 15 trials here. So let's do that. Whoops, not that big. N is 15 because we are interviewing 15 people. The probability of success was 10.2% or 0.102. And we wanted the probability that we got 3 or fewer that were unemployed. So I want less than or equal to 3. And let's hit enter. And there we go. So the probability here of having 3 or more of the 15 that were interviewed, 3 or fewer of the 15 that were interviewed to be unemployed is 0.94. That's pretty high. 3 or fewer means that x is 0, 1, 2, or 3. So we could have just computed each of those probabilities and added them together. So here you have the probability distribution for this binomial distribution displayed in a table on the left side of your screen. And you can see the probabilities that x is 0, 1, 2, or 3. And if we add those up together, you can see that we get the same answer that we got from the calculator on the last slide. Because Because the binomial probability distribution models the probability of discrete random variables, you need to pay close attention to language. Unlike with the normal distribution, it matters whether or not we include the endpoints. If we say something like more than 5, that means we're going to start at 6, right? 6, 7, 8, all the way up to n. If we say 5 or more, or at least 5, that means we're going to start at 5, so we'll have 5, 6, 7, 8, all the way up to n. Notice that the second case includes the probability that x equals 5 in the sum, while the first case does not. We didn't have to worry about this, again, with the normal probabilities, because with continuous numerical variables, the probability of getting 5 or fewer was the same as the probability of getting strictly fewer than 5. Let's make sure that we're comfortable with the language. If I say more than 6, what x values do I need to include? Well, this means more than 6, so I'm going to start with 7, 8, 9, all the way up to n. What about fewer than 5? In this case, I'm going to start at 0 and go up to 4. I don't want to include 5 because it says fewer than 5. What about at least 7? When it says at least 7, that means I'm going to include 7 as my smallest possibility, and then I want to list everything greater than 7. So 7, 8, 9, all the way up to n. Between 3 and 7 inclusive means that I'm going to start at 3 because I'm including that endpoint and go all the way up to 7. So 3, 4, 5, 6, and then including 7 as well. Finally, at most 4 means that I include 4 at the top, and I'm going to list everything less than 4. So 4, 3, 2, 1, and 0. At most 4.